But then in today's video, you'll be able to build and assemble your own step-by-step compliant wheel design to pick a ball up and off the floor with the robot. I'm Brogan and I've been teaching robotics design for over a decade now. And one of the hardest skills that a robot can do is to pick something up and off the ground. So I'm going to get you started with a really basic, simple starter compliant wheel design that works pretty effectively at picking up a 12.5 centimeter diameter ball. And then I'll also tell you some ways you might improve that design to make it your own. So to get started with the assembly process, you're going to need some sort of drive base here. I'm using a modified Swift drive base, but realistically anything will work. AndyMark, Rev, GoBuilda seems to be the main setting that I use. You're going to need a few tools for this: 7mm wrenches or a nut holder, a 2.5 and a 3.5mm screwdriver, and you can either use Allen keys or a T-shaped handle for that as well. I like to have all of them because it really does help make my build process a lot easier. And then these are all the parts you're going to need. You're going to need a few different 3D printed little ramp pieces. I've been lately preferring to print these things out of PCTG as opposed to PLA or PETG. PCTG is not much more expensive than PETG or PETG, but it is significantly stronger and much more impact resistance, which is what I really like about it in robotics applications. You need a few different slim U-channels and some really mini U-channels from GoBuilda, some half pillow blocks, a couple long axles. You can use couplers instead to be able to attach these two axles together. I've taken a through-hole sonic hub and a threaded hole sonic hub and put them together so that I can clamp each side of my axle respectively. Or you can just get a really long axle. The whole motor we're going to be using to drive this is Rev's ultraplanetary motor. But GoBuilda sells a few parts here that allow you to adapt it into the U-channel part and then also to a 7mm output shaft. I'm using a 5:1 ratio here so that this one goes at about 1200 RPM. A good rule of thumb is whatever the RPM of your drive motors are, your intake should be running at about twice that speed. So mine are about 450 and this is running about 1200, so it's actually running a little bit fast for what it is that I need. So I would probably reduce this a little bit to try to get a little more torque with some for external gear ratio if you were to improve my design. You're going to need some plastic chain and some 10-tooth sprockets, and then some sort of compliant wheel. Now the compliant wheel here is where a lot of that magic actually comes into. This is a Swift wheel, but you don't need a Swift wheel particularly. You can use an AndyMark compliant wheel. You can use a Rev compliant wheel. You can use a GoBuilda compliant wheel. Does not matter what compliant wheel you're using, just as long as it's got a good amount of squish, good amount of give. I really like these Swift wheels because they also have these little spikes here that you can cut out or cut into, and then you can make your own boot kicker out of them, as opposed to having to buy a whole separate product, which is kind of nice. And you can also have it rotate this way so the spikes hit it and wants to kick the object up, or it wants to scoop the object more in. So it's up to you as to how it is you're going to end up playing these. Mine are about 70mm in diameter. If you want this whole CAD file, you consider joining my community down below. I've got it all linked in the description. You're also going to need some of these laser cut out parts. I've cut these out of acetyl. You could also do it out of acrylic, or you could also do it out of polycarbonate, and some of these little block mounts so that we can actually mount these things together. Now, most of my designs are built with things that you can find just kind of laying around that your robotic shop likely has already, and I try to stay platform agnostic if I can. Last thing is a quick note on ball bearings here. There are two different thicknesses in ball bearings. There's one that is 4mm thick. There's one at 5mm thick. It's an outer diameter of 14 and inner diameter of 8. Now, GoBuilda sells one that is 5mm thick. You can buy a standard ball bearing that is 4mm thick, and in my experience works just as good, and then you don't have to buy the specific parts from GoBuilda. You can typically find these in any local hardware store as well. So I really like these. So I'm going to grab a couple 10 length U-channels. You can grab whatever length it is that you want, and a couple 8mm screws, and some of these little half pillow blocks. Now keep in mind on these pillow blocks, they do have a low side and a high side, so that when I line it up on a slim piece of U-channel, you should be able to get yourself flush with the edge here. Whereas if I flip it on the other side, you'll notice that my holes no longer line up on the inside there. So when I flip that back around, my holes now line up properly and I can put my mounting screws in here. So I like to use 8mm screws because if you use anything that is too long here, you're actually going to go through the edge. And you can see right here that I've actually gone through my bolt here, and then as you try and drive another screw in, you're actually going to end up bottoming out on that screw. So I have to make sure that I actually do grab 8s. Somebody's put some 10 millimeters in my 8 millimeter screw bins. One of the sides, we're going to go ahead and mount it fully on the sides here, but on the other side, on our robot's left-hand side orientation, we're only going to put one pillow block in because we're going to mount the motor on top of that one. So in this side, we need to be able to mount it the outside like so. That is the robot's right, and this will be the robot's left. So on this one, I'm only going to mount the bottom on our U channel here. And with these Allen keys, you can use a 3 millimeter Allen key, you can use a 3 millimeter screwdriver, you can use a T-handle. Doesn't matter what you need. It's kind of nice to have one tool for the specific job that it is that you need to do. So now we've got those set up, we can actually go ahead and mount this onto our chassis as well. And for this one, I'm going to count over 1, 2, 3 holes on the inside. I'm going to mount it so that we are just up to almost the edge of this third hole here. So let's flip this around so that we can actually get in and put in some screws here. And then I'm going to grab a couple 8 millimeter screws to make my life simple. Oh, I grabbed my 2.5. I'm going to count over 1, 2, 3. Oh, and this is a case where I need to use my Allen key because I am not mounting on. So we'll put that Allen key all the way through a hole here, and that allows us to actually get our hole through. We're going to mount, on this U channel here, there's like the actual U side. We're going to mount the U side to the inside. So I'm going to go ahead and start screwing this down. Oh, I'm actually one screw over too much. And there we go. I'm going to mount my wires to the outside of this as well for my actual drive motors so that I'm not having my artifacts or whatever piece that I'm attempting to intake come straight in. So this is where a ball-shaped Allen key can really help you out. We'll go ahead and do the same thing on the bottom here. I've got to get up there to line up those holes. There we go. And you may need to find that you need to wiggle this piece left and right until you can find that space that it wants to actually sit inside of. There we go. That's nice and sucked down. Now on the other side, we're actually not going to make this symmetrical. And the reason being is we have a different set of mounts. We're going to grab the U channel that only has the one piece on it, not the second piece. And we're coming over and we're actually going to mount it about 2 holes away from the third. So we're actually going to be using these center slots as our mounting holes. So I like to push my Allen key through, put my screw on, and then that makes it really easy for me to find that hole that I'm looking for. And give that a good little snug. We'll do the same thing, come through the slot on that side, come through the slot on the other side, and then we got to find our hole. There we go. I felt that one catch. Give it a good little snug up. And there we go. Now we'll reorientate ourselves back here at the very top on this side like so. We're going to mount it from the outside here. So I'm going to grab a couple more 8 millimeter screws. If you are going to be using this in a long-term design, I highly suggest at this point that you throw in some Loctite. Now I just realized that I mounted mine on the top here, but this is actually a 10 length U channel, whereas the CAD design calls for an 8 piece. So I've actually had to mount this a little bit lower so that we can run into that problem. Now it comes time to constrain our whole system together. So what I'm going to do is I'm going to grab myself a 10 piece U channel here and some more 8 length screws or 8 millimeter length screws. And we're going to go ahead and mount this down up at the top here before we start working on these side plates. Again, not wanting to use too long of a screw here. Now, what you want to find is you may need to flex this part out so that you can get your holes properly aligned and you don't run into your whole unit not being square. So this top brace is important because it allows our whole piece not to flex in and out, like so. Now let's go ahead and let's start working on some of those side plates that we're going to use for our acetal. So on the 8th hole up here, I'm going to grab a ball bearing with my flange, and with my flange on the inside of my rover here. And then I'm going to grab a small axle here, 30 mil-ish, that's got some sort of E-stop at the end or E-clip at the end. So I can then punch it up like so through that ball bearing. I'm going to grab our acetal sheet. We're going to make sure that we place our holes towards the top of the unit, not towards the back. And I'm going to throw another ball bearing onto this one, this time with the flange facing on the outside so we can have some nice rotation here. And then I'm going to put a clamp on this to hold this whole system together. We'll go ahead and clamp that on like so. And now we've got a nice snug fit there. Nice thing about using acetal in this portion as opposed to something like polycarbonate is that acetal is self-lubricating, so it is going to slide and slip along our aluminum piece here a lot nicer than something else might if we were to say use polycarbonate. Coming up on the motor side, we're going to go ahead and do the exact same thing, making sure that these two holes are facing up. So I'm going to go ahead and take one ball bearing. I'm going to place that in like so. And on this one, we have to add a second ball bearing as a spacer here, because otherwise what's going to happen is we're going to end up running into our mounting screws here on this hole. So I'm going to take one more with the flange now facing out this way, but we're going to put a shim between these two ball bearings so we can actually have these things rotating around. Pop that on like so. Now we have a nice, smooth spinning section, and we can put our sprocket on the outside to be able to constrain this whole system together. And on our sprocket, we've got a couple set screws that we can go ahead and tighten in. Now we've got that subsystem put together. And now we can go ahead and put our cross brace here across the two, and that's going to hold and constrain our whole system together. Now on these side plates here, you could use a thin PCU channel like so. You could also use a thin PCU channel across the middle to brace. Problem with using one of these is that then your side piece wants to try to hit the side of these panels here, and you also don't have a convenient place for that chain to actually go around that sprocket, which can be a little bit annoying. So now it comes time to put in these little block mounts. And these block mounts have a hole down here on the bottom, and that's where we're gonna mount to the bottom of our plate like so. I'm gonna grab a bunch more 8mm screws, and we'll start threading in the bottom of our block mount, making sure we keep this nice and square. We'll do the same thing on the other side. And on these block mounts, one of the side has a short connector and one of them has a long piece of connector here. You like to mount them in such a way that they end up being flush with the top of the acetal and or polycarbonate sheet, depending on what it is that you are using in this case. You may also find with acetal, so you don't want to over torque these, because you can actually start compressing into the plastic sheet itself. You could also use a sheet of ABS plastic for this too. So now these parts line up on top here to give ourselves that little bit of bracing, so we can use some more 8mm screws here. For my acetal sheets, I like to use 4mm acetal. I find that it's a rather functional, it's a good balance between thickness to add a little bit of rigidity to our system, but also keeping things nice and light so that we don't end up running into some issues with too much weight being on their system. Although in this case, on this design, we actually do want a little bit of weight on the system for it to be able to drop back down sufficiently. So we'll go ahead and shore these up. And what this helps us do is this just helps these stop from flexing out and this whole system stop from racking a little bit. So that is a lot better, what it is that we're looking for. So now we can actually start putting on our main axle here for those compliant wheels. Now I don't have an axle that's long enough to actually run across here. So what I've done is I've taken a couple of these Sonic hubs and I've clamped them together. You can also just use a standard coupler. So you can slide one of these through, go ahead and clamp that down and clamp that one down. Do the same thing on the other side. We'll go ahead and clamp this down and clamp that down here, like so. Now we can actually start building our little shish kebab here for the intake. Now on these on these Swift compliant wheels, there are these little nubs here that you can actually cut off to make these into boot kickers, or you can cut these nubs off and make them into standard wheels. For me, if you have them running in this direction, it's going to want to kick an object up, whereas if you have them running in this direction, it's going to make it a little smooth for that. And in my case, I actually do want a little bit of lift here, so I'm going to try running them in this direction. And if I find that doesn't work very well, then, I'll end up flipping them around. So I'm going to slide 2 onto this side like so. I'm going to slide 2 onto this side like so, making sure that my wheels are turning in the correct direction that I want. Once I've got my shish kebab here, I can slide it through one side like so, and through the other side. And this is what's actually going to provide that weight to be able to always want to lift our arm back down. Now I'm going to take another flange ball bearing. I'm going to make sure that the flange is on the outside of the robot this time, like so. I'm going to take a clamp, and I'm going to run that clamp onto that ball bearing. Make sure that I'm somewhat even. Now I have too long of an axle here, and that's okay. I'm just running this as an example here. You might want to reduce the size of this axle on your design. I'll throw in another ball bearing here. And for this one, as I push that into the acetyl, you want to make sure that you're not clamping this too much and not opening it up too wide. So you want to let it rest in its natural position, where we can then put a sprocket on and have that hold it like so. And this sprocket and the other clamp are going to hold this in position to allow it to spin without these flicking or coming apart in this system. Now we can start throwing on our chain for our main system here. So I've got a full video on making and breaking chains in the description down below, but I always find having a set of pliers and a slot screwdriver very, very helpful in this case, because that slot screwdriver lets you take that, snap that chain out, and the needle nose pliers here allow you to be able to grab these things in and twist them on easy like so. So what I'm going to do is I'm going to grab my edge around. We'll go ahead and wrap this around, and we need to find a point where our chain is actually going to connect. So I'm going to decide where that's going to be in about the middle here. And as I wrap this around, I can line it up like so and say, okay, I'm going to have to break it right about this point here is where it wants to snap, because that's where it wants to sit together. So as I give that little twist, oops, as I give this that little twist, that chain likes to break apart. We'll check that we did indeed make it the correct length. I think I just split it one too short. So I'm going to add one more onto there, unfortunately. So let's snap out one, add that in, like so. Beautiful. And now we can go ahead and connect the whole thing together. And I'm going to show you the cheater's way of mounting this sprocket here, because it can be a gigantic pain to mount these in. So what I'm going to do is I'm going to mount it around this sprocket like so. Then I'm going to put this other sprocket on, mounted like so here, and then simply push that onto my axle like so. And that makes it way easier to get my sprocket on in its eventual resting place. I also like to use my screw here, or my screwdriver, to be able to twist this around. And now we've got a nice frictionless system here, friction-free, ready to rock. Now it comes time to decide where we're actually going to place these wheels. I like to have them about evenly spaced. Now before we constrain these down, we need to figure out where to place them. We should probably put in our little guide rails first here. Now on these guide rails, they do have a large opening bored out hole that makes it a lot easier for you to be able to mount them in on the sides here. And what these are going to do is these are going to help shape the balls in, or the artifacts in, so that as they come in, they're more likely to come into the compliant wheel section if we get into some wrapped up something like a wall. So let's change our view angle a bit here. I'll grab some 10mm screws, and I can through bore them right through like so. Oops. Actually, I might need to use more than 10mm screws there. Let's grab some 16s, because apparently that's a rather much longer than I expected. So let's grab some 16 screws here, push them through, and some lock nuts. Oops. There we go. That's more where we want it to be. And now you can either use your, oops, that is definitely not the hole that I want to be in. That is the hole that I want to be in. Now you can either use a screw holder here or a wrench, put them in. Now I'm going to start getting these just finger tight for now to make sure that I'm actually lining up on all of my holes. And some of these screws are actually probably a little short. I probably want to use a little bit longer here because as you can see, I'm actually not fully getting into the nylon on the lock nut itself. And if you don't get into the nylon on the lock nut, you're going to have one heck of a time with these things actually backing out and vibrating. Again, I'm not using this for particularly long, but on yours, I would highly suggest that you do so. And on these ones, I'm not clamping them down like crazy because otherwise I'm going to start eating into that PCTG too much. We'll come around, we'll flip it on the other side, and we'll do the same thing. Now you might need to find that you might need to change these angle brackets slightly on your design depending on what drive system it is that you are using. I'm using a Swift drive system, and such I've cut these in so that it mounts around the wheel itself, but you might need to find that you use a slightly different design in the end because maybe you're using a slightly different mechanism chassis to mine, and that's okay. I'll go ahead and clamp these in. Oh, that's way too small of a screw. Somebody's put that back in the wrong bin. And actually, my screws are holding in just fine here. This PCTG is rather sticky stuff, so I'm actually not even needing to hold those down with a screw, which is surprising. Okay, so now that we've got those in, now we can actually think about where we're going to be constraining our wheels. And we're going to grab an artifact to help us with this. So I'm going to grab a ball here. And what I want to do is I want to line up on a place where I'm going to be hitting that wall and where I'm actually going to be connecting that ball first. So it looks like actually right on the outside is probably what I want, and somewhere probably more here and here like so, and maybe in just a little bit. So that actually looks pretty darn close to what it is that I wanted the system. So now I can grab some zip ties and we will screw these on. Well, not screw. Zip ties, zap straps, whatever you want to call them. Sometimes they're called cable ties, sometimes zap straps, sometimes zip ties. And I can never remember if that's just a Canadian thing to call them zap straps, or if that's just whatever my father called them growing up. This is a strap that zaps. It is not a tie that zips. So I guess it depends how you define your automatopoeias. So we'll put this one down one more, and we want to be roughly equidistant here. And nice thing about the zip ties is it'll allow us to move these around as we need without them totally running out. That's one thing I wish about these Swift wheels, that they had a bit more of a tighter bore on the end here so they didn't run in. And we'll grab some dual edge bevel cutters here just to go ahead and snap these nice and flush. Otherwise, we'll end up going over our sizing constraints with our cable ties. And actually, I've seen some teams even use cable ties as a legitimate boot kicker system. And I thought that was pretty creative from them. Okay, now that we've got our system in here, last thing we need to do is we need to decide an actual resting height for this system here. And we're going to do that by using these balls here and then figuring out where these heights are. Then we can use a standoff, or we can use a screw here to be able to put that in. So actually, I'm pretty happy with that height as a resting point, and that's probably going to be a little bit too high. So now we're going to have to find a resting point that this thing's going to want to sit on, where we're still going to get some compression, but we get a little bit of lift up whenever the ball actually contacts on there. So it looks like that's probably pretty darn close, maybe a little bit lower, honestly, for where it is that we want those to be sitting. So maybe we want something a little more like that. So we get a little bit of that lift up with our system as it comes in. So it's going to want to come in and it's going to lift itself up. So I think that's actually a screw that I'm pretty happy with. So if I were to look at my system here, I'm actually going to put it down on the 6th hole, and we can just kind of loosely constrain this with a nut here. And let's go ahead and tighten that down. Actually, let's use a much smaller screw here, because that nut is what's actually going to end up holding this one in place I want to make sure we do the same thing on the other side, because that is that little resting bar that makes this whole system work. So we're going to be, let's flip this over onto the other side. And we'll do the same. So instead of a standoff here, I'm just using a standard axle that we can slide on, and that will be our standoff on this side. Now, it doesn't really matter at this point. I wouldn't say this is the fanciest of solutions, but it is one of those things that works. You probably want to find a slightly better solution. But now we've got a bar. Oh, did I put in the wrong one? Okay, so now our arms rest against these bars and this nut, as opposed to just falling onto the ground. So that's more what it is. But look, as this thing runs around, it should want to pivot itself up. And as it picks us up, it also gives us that right amount of appliance that it is that we need. Now, last thing right now is if we were just to run this in, it's just going to hit into this bar. So we need to have some sort of angle system here. So I've got a 10 centimeter sheet of polycarbonate here that I've already pre-drilled some holes inside. And I'm going to go ahead and do a little cut and a snap method here. So for this one, looks like we want to run it about like so. So I'm going to do a little cut in there. And what you can do is you can take a sharp knife, do a little score cut, and then a little deeper, and a little bit deeper. Put it on a flat edge, give it a snap, and you end up with a nice snap sheet of polycarbonate there. Is after doing a little bit of testing, I found there's not enough weight on this to be able to bring back down successfully all the time. So what I've done is I've taken a rubber band, I've wrapped around the main arm here, and put a little pin here to allow itself to keep back down. Because what happens is these balls come up with so much force that they would actually kick this whole intake up, and then it would cause this whole thing to rock around, wasn't able to consistently pick up more artifacts here. So I've run that through, and that's made it a lot more successful having that. I've also added in a very simple little ramp here with some support on the bottom. Just we have a pretty steep ramp. This is about a 10 centimeter sheet of polycarbonate. You could also use acetal or 3D printed plastic, whatever, just as long as it's close to the ground and it has some support on the bottom so it doesn't flex in on the bottom. If you'd like to get access to the CAD files for this compliant intake, you want to make it yourself, you can consider joining my community down below. If you got questions about how this compliant wheel intake works, let me know in the comments. I'll do my best to answer them. As always, best of luck on your next robotics project.